Today, I am going to cover up process introduction, PCB, and context switching. So, firstly, I am going to discuss what is program, how a program becomes a process, what is the role of the process control block, and how context switching takes place in the processes. So, firstly, coming on the program. As we know that whatever we write in a file is known as the program. That may be a Word file, that may be a PDF writer, that may be a text file, anything. So whatever we have written known as the program. A program is an executable file that resides in the secondary memory. When we save it, it goes to the secondary memory. It is a set of instructions stored in the secondary storage device that is intended to carry out a specific job. For example, it may be addition of two number, a program that is written by a user, that may be a calculator, that may be a disk fragmenter, anything. It is a passive entry that reside on the secondary storage. Therefore, a program is termed as a passive entry. Why it is known as the passive? Because it is residing in the secondary memory, not in the primary memory. When that program brings up into the secondary memory to the primary memory, it is known as the active entity. So at that time, it becomes a process. So example here, calculator.exe that resides in the Windows System 32 and the file is known as the lc.exe. Similarly, in the Linux system, in the bin directory, there is a program that that is known as the ls resides in the bin directory. So these are the basic programs. Now, process. When these programs brings us into the primary memory from the secondary memory is known as the process. So now they are going to execute. Still, it reside in the primary memory, but these are known as not the process. When CPU execute these, then it is known as the process. So the process is termed as the active entity since it always is stored in the main memory and disappears if the machine is powered cycled, means power off. Several processes may be associated with the a same program. For example, I have written a program to take the input from a file to send the output to the printer. So a program may have several associated processes. On a uniprocessor system, multiple processes can be executed simultaneously because there are number of processor. Processor 1 is executing something else, processor 2 is executing something else, and so on. While in case of uniprocessor, only one program can execute at a time. Although we think we are writing a program, we are listening a music, or along with that we are copying a file, but actually the switching is too fast to our eyes or to our ears, or we can say the time duration is in the milliseconds. We think the processor is doing all the work simultaneously, but actually in uniprocessor system one process can execute at a time. So it is the illusion of concurrency to us. Now, process. A process is a sequential program in execution. The process is defined as a fundamental unit of the computation of a computer. When a program brings up into the main memory, that is the primary memory, so it is divided into for that a specified memory location is allocated to it, And this memory location is divided into the four parts. First one is the text, data, heap, and stack. Heap and stack are always resides upper and lower part as shown in the figure because these always grows or may grows. Text contains the program code that is of the fixed length. There is no need to increase, so it is at the bottom of the specified memory. Then after data that contains the global variable, it is the upper part of the text. Then after heap, because it may be possible there is a need of the dynamic memory allocation, and so there is a need of the increase the size of the memory. So there is a heap that will dynamically allocate the memory from the this specified space. Then after stack, stack contains the temporary data such as function parameters, return value, local variable. Whenever a function move from when a program moves from one function to another function, so it has to store some variables at for the timing or the temporary. So it needs a stack. So it also grows up. So it can take the space from the this empty specified space. So stack and heap always grows. So these are specified nearby the empty space. PCB. PCB stand for the process control block. Whenever a process is bring up into the main memory, a PCB is assigned to it in the ready queue. When a process fetched from the job pool. Now, what is job pool in new terms? Job pool means the secondary storage, means program where resides that are not the process, that are the program. So secondary memory is known as the job pool in general and assigned to the ready queue. Ready queue means brings up into the main memory. The ready queue is in the main memory. A PCB is assigned to it. That means whenever a process is bring up from the secondary memory to the primary memory, that means RAM, a process control block is associated with the new incoming process. The process control block is used to store the information about the process, and it is also called a data structure which stores the information about that process. Means corresponding to that particular process, whatever the information is needed, necessary information is stored in the PCB. So what will be this information? The information may be process state. During the life cycle, a process may reside in the different state. In general, the process has the five states, but depending on the operating system, the state may differ. In our curriculum, we will discuss only the five states, but the Linux has the or Unix has the nine states during the its life cycle during the execution. So process state, then after each process is uniquely identified by a number that is known as the PID. Then after program counter contains the address of the next instruction, registers, memory limits, list of open files, etc. Accounting information. There are lots of information, so we will discuss one by one. Process state. The state may be new, ready, running, waiting, halted, and so on. So these are the in general five state: new, ready, running, waiting, and halted. In general, program counter. The counter indicates the address of the next instruction to be executed for this process. Means which next instruction will get executed. CPU registers. CPU registers depends on the architecture of the processor. It may be 4 register, 8 register, 16 register, it depends. It These register includes accumulator, index register, stack pointer, general purpose register, etc. So there are number of registers. The processor which have more number of register may get execute the program faster. This is the general concept. Then after CPU scheduling information, the information include the process priority. For example, I am executing a process and there is a higher priority process brings up into the main memory. So the process which I am executing, I means processor is executing, will stop its execution and serve that higher priority process. So this is the basic scheduling information that contains the PC inside the PCB. Memory management information. For example, suppose that we are working on a multi programming system. Sorry, we are working on a multi programming system. So in the multi programming system, this is our main memory, and this memory is taken by the OS. Rest of the memory is taken by the processes. This is the process P1. This is the process P2, and so on. So at present, the process P1 is getting executed by the processor. This process is executing by the processor, but the process P2, which have the higher priority than the P1. So this when this when this P2 process brings in into the main memory, the execution of P1 process get halted and the processor will be given to the process P2. So this is the concept. So here memory management information, thus it may include such information such as value of base register, limit register, base table, segment table, depending on the memory management system. So here, just as I was discussing, this is the memory. So this is OS taken by OS. So this is the process P1. This is for the process P2 and so on. So from which location the process P1 will start to occupy the space and from where it will get ended. Suppose that it is the memory location 2001. I am taking it into the decimal. Actually, it is in the binary, or we can say in the hexadecimal. That is understood by the CPU or the computer. And suppose that it ends at 3999. So the space occupied by the process P1 is this one. So the process boundary limit register. So this is the base register and this is the ending point where after which the second process will get started. So this is all about the information that reside inside the memory management. So the PCB also contains the memory management information. Along with that, it contains some accounting information. For example, suppose that I am using a round robin scheduling algorithm and we can say in round robin or this happens in the round robin algorithm, each process is allocated a particular time slice. For example, I have allocated a process that requires 10 milliseconds to get execute and in the round robin scheduling algorithm, a 2 millisecond time quantum is allocated to the each process. So there are 5 processes, each will get execute only 2 seconds. Then after it has to bring up into the ready queue again. First process P1 will get execute for the 2 millisecond. Then after it will get suspended. Process P2 will get executed for the 2 millisecond. Then after it will get suspended. Then after process P3. So each process will allocated a particular time slide, that is the 2 millisecond. Suppose that the process P4 requires only 1 millisecond. So it will get terminated. So we will discuss this in the next video. So accounting information means uh, how the real time used by of the CPU by the that particular process, time limits, account number, job means PID, job PID number, etc. So this information, this is the accounting information that is taken care by the PCB. Input output information. Input output status information includes, for example, a program may require the input from some file. So how many file it has been already opened, okay? Whether those file has been closed or not. So such type of information is also contained in the PCB. So this is known as the input output status information. Context switching. Switching of CPU from one process to another process requires perform state save of the current process and state restore of the different process. Means whenever a process switch a processor switch from one process to the another process, whether this may possible its time get expired or a higher priority process may bring subs into the main memory. So the lower priority process will get suspended. Before suspending, its information must be saved to the main memory from the registers, and the newly bring up process information must be stored into the registers. So this concept is known as the context switching. Whenever when a when a context switch occurs, the kernel saves the context of the old process in its PCB and loads the saved context of the new process to run. Context switching is a pure overhead. For example, if I am doing something and I am interrupted by some process, higher order process, or if my time slice get expires, so I have to save the currently executing process and then after load the newly incoming process. So at that time processor will not do any useful work, so this will be automatically an overhead. Switching speed varies from machine to machine depending on the memory speeds, number of registers, and existence of special instruction such as single instruction to load or stores or registers. So these are the factors that plays an important role during the switching. Typically, the switching time in the milliseconds. So here is an example of the context switching. Suppose that process P0 is executing and interrupt occurs that your 2 millisecond time slice has been expired. Now, the processor will save the states of the process control block of process P0. Here it is represented by the PCB naught or PCB 0. Then after it will load the new process, that is your P1. Okay. So in that case, here until it will not save the currently executing process and load the new PCB corresponding to the process P1. The processor will be ideal. Then after, it will execute the process P1, and when the timer of process P1 get expired, it will now, it is the execution state. Now it will save the, as the timer expires, it will save the process P1's information into the PCB1, and after saving, it will load the old process, that is the PCB not. PCB not yani that means PC process P not into the into the memory for execution. So again, here this is the ideal time. CPU will not perform any fruitful work. So during the context switching, here the PCB processor will be ideal. Here the PCB processor will be ideal. Now the execution time for P naught will be from here to here, because loading and unloading and loading of the process P naught, and similarly process P1. So it will the overhead for a processor, because processor will sit ideal and it will not perform any useful work. So this is known as the context switching. During the examination, this may be asked, discuss the context switching with the suitable diagram. So you can explain this diagram for the context switching. Now, the question may arise from this chapter, this video. What is the difference between program and process? What is the need of the PCB? What is context switching? Discuss the context switching process, how it take place. Justify the statement context switching is an overhead. So I am completing this video here. Thank you.